Hey everybody, this is Larry, this is me going with Q3 of the bi-weekly contest 112, maximum sum of almost unique subarray. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this problem. This one should be standard, at least in principle. I mean, obviously everyone's at a different place, so you may struggle a little bit depending on which part of it, but the core idea does come up a lot in Leetcode, so if you're not able to get this one in implementation, at least get it an idea. And of course there are hundreds probably on Leetcode at this point of problems similar, and that is the concept of sliding windows. And basically the idea here is of sliding windows is a sort of a greedy algorithm, or maybe not even greedy, maybe just like a brute force algorithm that basically you check the answer, or you check all possible cases, but in a way that builds off previous cases, right? So for example, let's say we have this, and I'm not going to look at the k, I'm just kind of a little bit lazy. Let's say okay, fine, k is 3, right? So the idea with this problem is that we're trying to look up every possible subarray of size k. So it's this one, and then there's like a couple of them, right? Like n-2, I suppose, for k is equal to 3. Now, so we look at every possible one to see what the answer could be, right? So, I mean, in that way, it is, you don't have to prove anything because you're literally looking at all possible subarrays, right? So in that way, it is, maybe you could say greed, I don't know, or brute force, not brute force, but just like exhaustive, right? And then the sliding window part is that if you look at where two adjacent queries, if you want to call it that, like between the first 3 and then the second 3 and so forth, the thing is that, and I'm going to delete the other ones, but don't worry, is that this, between these, you know, going from 599 to 992, right? There's an the key point is that the overlaps of two things, and so we're trying to reuse what we know from the previous answer and kind of incrementally go on top. And in this particular case, we want to add the 2 and then delete the 5. And that's basically the core idea behind sliding window for this problem. After that, it becomes implementation, because then now we're just asking, okay, how do we query that it has m unique elements? How do you keep track of the sum and stuff like that? And this is the part that we'll go through together, of course. Right? So basically, yeah, I just keep track of a counter. Of course, this is, you could also use like an array of 26 elements or something. Or wait, no, that's not true. I lied. I thought it was the alphabet. Never mind. So here you do need a dictionary or a lookup table with a frequency table is what I have, essentially. And total is going, total represents the current sum within, in a subarray. And best is going to be basically the result, right? Your best of all the possible subarrays. And here, when we slide in, we add it to the sum, because, you know, you do a slide in, and we add the count here, and then we add the total here, right? And then here is that, okay, if we have too many elements, this may look a little wonky, but this is basically saying if we have k plus 1 element, remember that if you go from 0, 1, 2, 3, ... to I, you have I plus 1 element. So if you have more than k elements, then you want to delete the one that's furthest to the left. I think maybe I'm mirrored, but you know, of one to the left, and then so you take it out, you delete, you subtract it. And this part is actually critical, at least in Python. Maybe in other languages you have to do something similar, but deleting the key now allow us to check the length, which allow us to get the size of the unique, the number of unique numbers, and then we could do a check that is greater than or equal to m, because this is saying that we have at least k, or well, in this case, exactly k elements. and we have k elements, and we have at least, or yeah, we have at least or equal to m unique elements, then we just update the best if it is the best. That's pretty much it. This is going to be linear time, linear space. Linear space is because that's the range of you know, this thing, so that could be linear space. And linear time because everything is O of 1 here, 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 here. So, well, if you assume that these are O of 1 dictionaries, I'm not going to get into that for this problem, but for this purposes, you can say this is linear time, linear space. Cool. That's all I have for this one. Let me know what you think. And during the contest, I did take a little bit of a long time to solve this because I had a typo. See if you can spot it while I type it. And you can see the live portion now. Same problem. It's pretty weird. Almost maximum almost unique. What's an almost unique? Oh, M pairwise distinct element. M pairwise distinct element. What's a pairwise distinct? K is equal to 4 and 3. That's just distinct, not pairwise, but well, pairwise distinct feels weird. Maximum sum, okay. Let's just slide in Windows, but the pairwise is kind of, I don't know if that's right. But okay, fine. M is, which one is M? K is the length, M is the uniqueness. Okay, fine. Size K. So this is 2. Should be 2. Yeah, okay. And this is 3. This should be 2. Okay, need to put in a thing. Which one is M again? M is the uniqueness. Okay. I took it out, but 26, 30, no, that's just wrong. Okay, fine. Why is it wrong? What am I doing? Okay. Oh, did I forget to delete? I did forget to delete. Still wrong. Correct for the last one, but oh, whoops. Silly mistake. Still wrong though. What, Larry? What are you doing? 26, 27, 26. Where am I getting 26 from? I minus k is greater than 0. No, that should be right. Wait, yeah, k is the sublet length, okay. Two, 8, 15. Oh, let's look. 2, 8, 15, 18. Okay, 19. But not subtracting 2. Why not? Am I just confused? 8, 19 and then 26. But why? Tell me why. What am I doing? Why am I so bad at this? Okay, 18, 22. Alright, did I put anything there? Okay. Why was I so bad at that one? Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm, this explanation, and how do you do on this contest and everything. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.